One more problem here that I'm going to rattle off today. I'll try to get some more later, but I think this will be my last one for today, anyways. And so it's problem 3, and it's once again relating the kinematics, linear kinematics, to the angular kinematics. And once you realize that, it's very straightforward. I'm used to a throwback to the old kinematic days when we did that in the first quarter, and everyone knows and loves those. So here's our problem, and with problem 2 that I did, I related it to the kinematics. And so let's go to my equation sheet here. We can go, oops, I've cut and paste the kinematics. So here's how they relate to each other. This is the same as this. This is the same as this. This is the same as this. Refer to your equation sheet to pull these out. You can use either ones you want. I'll try to relate them to both here and go from there. So there it is. So let's pull out the information we do know here. Okay, we know that time is 2.92 seconds. Good, that's good. We don't need to do anything with that. Starts from rest. So V initial, which is also W initial, is 0. And we can put any units we want. 0 means you can put any units you want. And so I'm going to put dGs per second. Now, then they also give us it does constant angular acceleration, and it turns at a rate of this many revolutions per minute. So this is the velocity final, and it wants angular acceleration, or alpha. So they give us the final velocity, or final W, and that is 238.012.123, and it is revolutions per second. It was here, right? But it's 4. 1, 2, 3. Oops, 4. So there we go. That's it. I just converted it. That's scientific notation right there. E to the positive 4 means times 10 to the 4th. So we need to convert this, though. This part 1 wants alpha, and part 2 wants delta theta. Okay, so displacement and acceleration of the two. So 3 of the 5, we're on our way to getting these done. No problem. We just need to convert this. And so to convert this, I want to multiply by 360 degrees, and that gives me a very large. Mistake. Sorry. This is not per second, that's per minute. Per minute. So we need to convert this. So let's just do this off to the side. Sorry. So we're going to go up here and we're going to convert that up here. Okay, this looks like a nice spot. 23800, and it's revolutions per minute. So you're going to do this, and you're going to do that 1 revolution is 360 degrees, and that 1 minute is 60 seconds. So in essence, you're going to multiply by 360 and divide by 60, okay, which is the same thing as just multiplying by 60, but I like showing out the steps. And we'll be left with degrees per second. So when I do this, I get 14,280 degrees per second. So this is 14,280 degrees per second. Okay, so now we want to solve, so we can use this equation, which is V final equals V initial plus AT, or if you'd like to call it W final equals W initial plus alpha times 10. Okay, so now we got this. 14,280 equals, this was 0 plus alpha we're solving for, that's an alpha variable, times our time, which is 2.92, and my alpha is equal to 48904, and our units will be degrees per second squared. Okay, now when Kappa will spit it out if you get it right in radians per second squared, but just don't mind that. If you got it right, and it just likes to give you radians. We can leave it in degrees when we put the answers in. It's fine. One thing you may be careful of is you may have to round. So in this case, you might have to round this to 48,900. So 0, 0, back to significant figure issues. But if you have questions about that, remember yellow doesn't mean you're necessarily wrong. So you just need to get to the right number of sig figs or the right units on it. Okay, so let's go to green here, and we can do now delta x equals v initial t plus 1/2 a t squared, or we can use delta theta equals w initial t plus 1/2 alpha t squared. Either one is fine, and we're solving for delta theta. Those are the same equation. So initial velocity is 0, so you can put a big fat goose egg right there, plus 1/2, and we now do alpha. Ooh, I'm running out of room. I'm apologizing right now. 48904 and times t squared, which is 2.92 squared. So, oh, I'm sorry. Ooh. So it's this delta theta is 1/2 your previous answer times your time squared, and I get a delta theta of 208,488, and my answer is in degrees. When you put that in, I had to round it to 208,500 degrees, and that's what, and then it spit it out in radians, which is no big deal, but that's what I had to round it to in order to get it to accept. All right, let me know if I need other videos. I know another student has requested one, and I need to get on that, but I might not get to it today. So, all right, thank you.